Alrighty, everybody. Welcome to the Morrison Planetarium, folks. Really quickly, I just want to introduce myself. My name is Christian. I want to be your planetarium presenter today, folks. And just a heads up, I'm not just a voice coming out of the walls. I'm a person, and I'm standing right behind you at the very top of the planetarium. Just want to let you know that I'm here, y'all. I'm a real person, not a robot or AI, not just yet. And want to again welcome y'all here to the Morrison Planetarium because everything that you see in orange right now is going to be one really big screen. Thanks to help us 6 different projectors hidden throughout our planetarium dome. And if you're looking for our projector system, it's hidden just below that orange glow. In fact, let me change it up in here a little bit. Let's change the vibe. And I'm very excited to have everybody here today because we are going to be doing one of my favorite shows. This one's called Tour of the Universe, and this show is completely live. So you're going to be hearing my voice for the next 30 minutes. And what this show entails, well, we're going to be starting close to the Earth, and we're going to be zooming all the way out to the very edge of the observable universe. So hopefully by the end of the show, you won't have an existential crisis of where we are in space. But just a heads up, we're pretty small in the grand scheme of things, so just a forewarning. And before we get started, I got to go over some quick house rules just so that we're all on the same page and have an enjoyable time. There's a few of us in here. First off, folks, there's no food or drinks allowed in. If you brought any snacks, make sure those are put away. We want to keep the theater as clean as possible. We appreciate your help. Also, if you happen to have any cell phones or smartwatches, anything that produces really bright white light, now's a good time to put those away for the next 30 minutes, as this can be very distracting and takes away from the planetarium show experience. And also, folks, if you need to exit early, the exits are always going to be at the very top of the planetarium, so always make your way up the stairs to exit. If you have trouble climbing the stairs, just remain seated for a little bit longer. We'll have someone escort you when the show is over, so you don't have to climb those steep stairs. And folks, this show is quite immersive. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity. There's a really quick and easy trick to ground yourself. All you got to do is close your eyes, take in a few big deep breaths, and then your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling across the universe, at least not more than the usual. But with that being said, folks, it looks like we're ready to go. So I invite y'all to sit back, relax, and let's begin our tour of the universe. Alrighty, everybody. As I mentioned, we're going to be starting off pretty close to the Earth, but not right on the ground. We're starting a little bit above it here at this really cool spacecraft called the International Space Station, or the ISS for short. And we can see the city lights just down below. And a lot of people tend to ask me, hey, Christian, what is the International Space Station? I hear about it all the time in articles and news online, but I don't really know what it is. Could you explain it for me? Well, of course, folks, the International Space Station is a research facility. It's a laboratory that orbits around our planet Earth. And they conduct all different types of science experiments up here with less gravity. Some of the experiments are things like what happens when you try to grow plants in space, which way do the roots grow. Another one is what happens when you try to spark a match in space. Does the flame act the same with less gravity? And one of my favorites is where they had two identical twins. One twin lived on Earth for about a year, the other one lived on the International Space Station for a year. After that year, they compared and contrasted the two twins. Turns out when you live in space for a long period of time, you tend to age a little bit slower, but not only that, you also lose a lot of muscle because you don't have gravity constantly working down on your muscles all the time. So if you plan to live in space for a long, extended period of time, remember to exercise daily. And folks, the International Space Station looks really big here in our Morrison Planetarium Dome, but it's not that big in actuality. It's only about the size of American football fields. If you've never been to an American football game, don't worry, you can also use the entire California Academy of Sciences, the museum we're sitting in right now. That's about how big it is. And also, this looks really far away from the planet, but it's not that far either. The International Space Station is only about 225 miles above the surface of our world. 225 miles. That's not too far. That's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend. So, only 225 miles above the surface of our world. And folks, this thing is going incredibly fast. The International Space Station is traveling at a whopping 17,000 miles per hour, where it orbits once around our Earth every 90 minutes, and it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. But folks, the International Space Station is just the first stop on our tour of the universe. So now we're going to see it slowly fade away to the city lights down below. And before we lose track of the International Space Station, I want to add a nice little orbital path so we can see it as it starts to slowly fade away. Alrighty, folks. Now we're able to see our entire Earth in all of its glory. And I want to let you know, folks, now that we're able to see our entire Earth, about the space program that we're using in here inside the Morrison Planetarium. The space program that I'm using here is something called OpenSpace. So if you go to your favorite search engine, type in OpenSpace, you can find the link where you can download this because you can use this at home if you want to fly through space, just like how I'm doing. But just a heads up, OpenSpace isn't entirely finished. It's a beta program, so we may come across a few bugs and glitches here and there. If we do, hopefully I'll point them out and we can look past them. And also, OpenSpace uses a whole lot of processing power and information. It's pulling data from satellites. So if you have an older computer, you may not want to download OpenSpace because that may overwhelm your computer. But if you got something new or a gaming computer, gave it a try, it's a whole lot of fun. And if you're a person like me that doesn't want to download anything, we have another great alternative called NASA's Eyes, just like the human eyeball. So go to your favorite search engine, type in NASA's Eyes, and you can fly through space just like how I'm doing, and it's so much fun. But in here, we're using OpenSpace. But now that we know what we're using in here, let's make our way over to our nearest natural neighbor to us in space, the moon. And folks, we humans have been to the moon before. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions. That brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science, and of course, they had some fun up here as well. They got to play some golf. But again, last time we sent humans to the moon was 1972, a little more than 50 years ago or so. But don't worry, folks, we humans are making a return trip back to the moon in the next few years, thanks to NASA's new space mission called Artemis. Pretty much with Artemis, NASA wants to send humans to Mars. But before we send humans deep into our solar system, we got to figure out exactly how we're going to be living out here in space. So the moon is the perfect stepping stone of how we're going to figure out the logistics of doing that. And what's really cool with Artemis is that they're going to be sending the first woman to the moon. But not only that, they're also going to be sending the first person of color to the moon. But not only that, they're also going to be setting up lunar bases throughout our moon. Pretty much our technology has greatly improved in the last 50 years, so we're able to conduct much more science in a much more compactable size. And one place that we definitely want to set up a lunar base is the south pole of the moon. The reason why is because we found ice there, and we can melt that ice and pass electricity through it, and we can separate the hydrogen and oxygen, and that's going to be very helpful when you're out here in space. So look out for any news about Artemis in the coming years. We humans should be heading back to the moon relatively soon. And folks, sometimes when we're looking at the moon here from Earth, it feels incredibly close to us. It feels like you can reach out your arms and touch the moon. But the moon's really far away. It's about 240,000 miles away from our planet Earth. Whew, 240,000 miles. Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for about 4 months nonstop, going about 80 miles per hour. Although I wouldn't recommend it, the roads out here are poorly maintained. Hee hee. And from here on now, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities because space is so big. So astronomers use a more convenient measurement known as light speed. And light travels at a mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind, so everybody say bye bye, moon. And now, folks, we're going to see the moon as it starts to slowly fade away. And just like with the International Space Station, I want to add some nice planet trails so we can see it before we lose track of the moon. So here are those planet trails. And folks, on our journey today, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to the help of computer models like OpenSpace showing us the most accurate images and information available to us. And now the nearest star to us, the sun, comes into view. So of course, here comes the sun. Do 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 do. And folks, the sun is also incredibly far away. It's about 93 million miles away from our planet Earth. 93 million miles. That is a good distance away. But again, in order for sunlight to travel that distance, it only takes sunlight about 8.5 minutes at the speed of light to get to the third rock from the sun, our homeworld, Earth. And this is a cool concept because let's say the sun was to turn off all of a sudden, it was producing no more sunlight. That last bit of sunlight will travel at 93 million miles, that 8.5 minutes to get to the Earth, and then all of a sudden the daytime on Earth would become nighttime. And again, this is such a cool concept because let's say we're looking at a star that's 70 light years away from us. We're looking at that star as it looked like 70 years ago because the light that just reached us took 70 years to get to us. So when you look at really far away objects in space, it's like looking back in time in a sense, which is really, really cool. But now that we got a nice bird's eye view of our solar system, let's do a quick refresher. Right in the middle of our solar system is the biggest thing, our star, the sun. Closest planet to the sun, we have Mercury, then we have Venus, Earth, that's us, and then Mars, the red planet. And then past Mars, we have this really cool thing called the main asteroid belt. And this is what it would look like if I highlight all those asteroids. There is a lot of them in this region. And then past the asteroid belt, we have the really big planets, the gas giants, the Jovians. We have Jupiter, the largest planet of them all. Then we have Saturn, famous for its rings. And then past Saturn, we have the icy gas giants. We got Uranus, the funny one, and Neptune. And of course, we can add everyone's favorite and lovable dwarf planet, Pluto. So here's the orbit of Pluto on screen. That's not Pluto, this is Pluto. And what you just saw right now is a, a bunch of things that share the same orbit as Pluto. So Pluto hangs out here in this outer part of our solar system called the Kuiper Belt. And you're probably wondering, what's the Kuiper Belt? I've never heard of that before. Well, the Kuiper Belt is what we just saw right now. This is the Kuiper Belt. And then pretty much in the Kuiper Belt, this is like a second asteroid belt. This is where you're mostly going to find icy asteroids and short period comets. And in 2006, folks, we found more than 400 objects out here in the Kuiper Belt region. Some of this stuff was bigger than Pluto. So we couldn't call all these objects planets. There was just way too many of them. So all the astronomers across planet Earth had a great big meeting. They had to figure out what exactly you need to be considered a planet. And they came up with 3 criterias. And folks, that was the day in 2006 where Pluto went from being a planet to a dwarf planet because some of these objects were bigger than Pluto. And not only that, Pluto doesn't clear its orbital path. It dances around its moon Charon. But that's okay because that's the really cool thing about science because as our telescopes and technology improves and we're able to see much smaller objects much further away, we're able to redefine these objects and get a better understanding. So that's the really cool thing about science. It's constantly updating and changing. But I'm going to put that Kuiper Belt away because that's just a whole lot to look at. And now I'm going to be putting on screen some many different spacecrafts we sent out in the 1970s to explore our solar system. Now on screen, folks, we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons, which flew by Pluto in 2015. Now, all of these spacecrafts are all traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventures, Voyager 1, has not traveled as far as light travels in a single day. In order for sunlight to travel all the way out to the orbit of Pluto, it takes about 5 hours at the speed of light. 5 hours, not too bad. But now, folks, we're going to leave our planetary scale behind because now we're going to be heading out into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us about 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. And I can see Alpha Centauri just on our right hand side. So, again, right in the middle is our solar system. A little bit to the right, you'll see a star that's moving just a bit. That's Alpha Centauri. And again, 4 years at the speed of light just to get to the next star system to us. But that doesn't put into perspective of how long it would take us humans to travel that distance. Folks, if you got on a rocket ship today, made your way over to Alpha Centauri, it's going to take you about 8,500 years. Whew, and that's just a one-way trip. But let's stop consider whether humanity has made its presence known beyond our solar system, folks, because now we're going to be stepping inside something called the radiosphere. And again, we're now inside something called the radiosphere. This represents the current limits of the most distant radio signals humanity has ever broadcasted or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. Now, this first began in the early 1930s with strong radio waves, early television, and radar signal, and then later, the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before that. But the earliest radio was not quite powerful enough to escape the Earth. And since all these signals are electromagnetic, they are traveling at the speed of light, so this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is constantly expanding at the rate of 1 light year per year, so is anybody out there listening? And now, folks, I'm going to be adding some many markers onto the screen. These markers indicate the many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we found more than 5,000 confirmed exoplanets in the nearby area to us, 5,000 other worlds besides our own. And that number is going to be increasing because we have new space telescopes that are being developed. They're being constructed right now. So that 5,000 number is going to be increasing in a little while. Now, to see if any of them are Earth-like with conditions suitable for life as we know it, well, we can't answer that question quite yet because the ones that are looking for that specific question are being developed right now. So it's going to be a few years before we can answer that question. But the more important point here is that quite a few of these planetary systems are within that 90 light year limit of our radiosphere and could have potentially received our signal. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. Now, to give you an example, let's say we live in this star system right over here. We find an alien civilization on the other side of our radiosphere. Let's say this one here. We send them a text message. We say, hey, we're humans. We live over here. It takes 60 years to get to them. They listen in, answer back another 60 years to get their message. Folks, that is a 120-year conversation in the making. Whew, and I can barely wait for a text message from my friend. But of course, folks, planetary systems beyond the radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And for now, I'm going to be putting away those exoplanet markers, and I'm going to leave our radiosphere up on screen. As huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way galaxy. Alrighty, folks, we're now looking down on our Milky Way galaxy. This is the galaxy we live in, and I've got to ask, can anybody see their house from here? Just kidding, we're too far away. And folks, our Milky Way galaxy is incredibly big. If you wanted to cross it from one side to the other, it's going to take you about 130,000 years at the speed of light. This thing is big. And not only that, the Milky Way is so huge, we estimate that there's at least 300 billion stars in our galaxy. If our recent discovery of so many exoplanets just within our small neighborhood, within this vast star city is any indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave our Milky Way, I want to show you what it looks like from the side. If you look all the way from this perspective, you're going to notice that our Milky Way kind of looks like a big pancake or a big frisbee. It's really flat. And this is important because when astronomers want to learn about the universe, it's much easier for them to point their telescopes galactically north and galactically south instead of looking through the plane of the Milky Way, which has planets, stars, gas, debris, things that block their view of the universe. So, again, we like to point our telescopes galactically north and south. Just keep that in mind. That's going to come in important in just a little bit. But, folks, the Milky Way is only one of many hundreds of billions of galaxies that comprise the known universe. So, in this giant leap, every single point of light that you're now going to see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. And we live in a local galaxy group which contains about 30 galaxies, large and small. It includes the nearest large spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door, and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And as our picture continues to expand, folks, you're now going to realize that galaxies are not evenly distributed throughout space, but instead they like to clump together in large groups and clusters with great regions or voids where there's very few galaxies. So we can see a lot of galaxy clustering right over here, some over here as well. We can see very few galaxies in this region. So you can kind of think of galaxies like people. They like to hang out together or they like to avoid each other. And now, folks, we've zoomed so far out, this picture that we're now looking at represents the closest 30,000 galaxies to us in a space over 300 million light years across. We got to give thanks to an amazing astronomer by the name of Dr. Brent Tully, who compiled this amazing representation thanks to the work of dozens of other astronomers working aside him over decades of time. So big shout out to Dr. Brent Tully. And now, folks, we have automated systems that are mapping even the most distant galaxies. So now we're going to be seeing the very large scale structure of the universe. And folks, this is the large scale structure of the universe. And remember, every single point of light that you're seeing, that's not a star, that's an individual galaxy. And just a heads up, our large scale structure of the universe is not in the shape of a bow tie or a butterfly. Remember when I mentioned that we live in a big flat spiral disk of our Milky Way galaxy? Well, if you were to line up our Milky Way, it would line up just like so, right down the middle from up and down. And again, we like to point our telescopes galactically north and galactically south instead of looking through the plane of the Milky Way, because it's much easier to see galaxies that way. But astronomers still want to make sure that there was galaxies through the plane of the Milky Way, so we had this nice purple survey right over here. You'll notice that they were still able to find galaxies, just not as many and not as far. Pretty much we have to wait for our technology to improve, and once that happens, we'll be able to fill in all these gaps that haven't been filled in yet, so it's just a matter of time. But it looks like we're running close out of time on our tour of the universe, so, folks, so we got to continue pressing on, because now we're going to be encountering these really distant, faraway objects known as the quasars. And the quasars are going to be represented by nice orange dots on either side of the large-scale structure of the universe. Here comes those quasars. And folks, quasars are short for quasi-stellar radio sources. These blazing objects are all billions of light years away. So now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So let's press back to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. And here we are, folks, at the very edge of the observable universe. And what we're looking at is something called the cosmic microwave background image, or the CMB image for short. And all evidence indicates that the universe that we live in is about 13.8 billion years old. This is data compiled by Planck and other radio telescopes. And this is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And this isn't your typical photo either. Instead, this is a temperature density image, where the light echoes of the Big Bang are color-coded, with the lighter areas corresponding to the hottest, least dense regions, and the darker areas, the coolest, densest regions. These fluctuations in temperature and density are extremely tiny. They vary no more than 1 part per 100,000. But these really tiny differences eventually gave rise to that large scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, folks, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But, folks, we only have one direction left to go, and that's going to be back home towards planet Earth. So let's find a nice entry point through all these quasars and galaxies. This looks like a good spot. And let's make our return trip back to planet Earth, everybody. Alrighty, everybody, we're crossing an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. We live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. And with that thought, everybody, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope. And there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we made our way back into our Milky Way galaxy. We're heading straight for that radiosphere, and we're making our way to our star system, our solar system, our small little neighborhood in the vastness of space. And now, folks, we're about to pass those spacecrafts we sent out in the 1970s to explore our solar system, passing the orbit of Pluto in the Kuiper Belt region, and making our way to the third rock from the sun, our homeworld, planet Earth. All the people that we know, loved, ever learned about in history all lived on this one planet. And now we're about to pass the orbit of the moon, the furthest we've ever sent humans out into outer space. And as we make our final approach back to planet Earth, folks, this is going to be the end of our Tour of the Universe show today. And I want to thank y'all for stopping by and watching it with me today. I hope you did enjoy it. But hey, look at that. We made it back home just in time for dinner time. And that's all for today, folks. Thank you for stopping by, and I hope you get home safely.